Hello, everyone. This week we're going to talk about do a refresher on differential equations. We want to find the solution to the differential equations, and we're going to do that by separation. This differential equation, we have dy over dx is equal to 2x over y, and we have a condition that when our x value is equal to 2, my y value is equal to 4. All right, so we solve these differential equations we're going to use separation. And how do we do it with separation? Where we get our y's and our x's on the same side. So not on this. We get our y's on one side and our x's on the other side. So that's what I did here. I multiplied y here and I multiplied dx here. So that gives me y dy and 2x dx. And next I'm going to take the integration of both sides. So we're going to get the integration of y. That's going to give me 1/2 y squared. And then when I take the antiderivative of 2x, that gives me x squared. And I need to make sure that I add my c. And so next we're going to use the condition that has been given to us to find the value of c. So basically, everywhere I see an x, I'm going to put a 2. And everywhere I see a y, I'm going to put a 4. And then I'm going to solve for c. So if you see here, again, this is a y, so I'm going to put a 4. I'm going to square that. So I got half of 16. Then I'm going to have 2 squared, which is 4. So my c value is going to be equal to 8. You can stop the video if you have trouble with the math. You can also email me. But I think that's pretty straightforward. Now I'm going to go back and plug in everywhere I see a c. I'm going to put a 4. So here I have 1/2 y squared is equal to x squared plus 4. I'm going to go ahead and solve for y. I first multiply 2 to both sides. So if I have this statement, it implies this statement is also true. 2 times 2x is 2x squared, and 2 times 4 is 8. Then I just need to take the square root of both sides. When I take the square root, I get plus or minus. But in this case, when I plug in my x value, well, what has to come out? A positive value. So I can't have a minus sign, so I get rid of the minus sign, and this is the answer to the first example. We get the solution to the differential equation is going to be y is equal to the square root of 2x squared plus 8. All right, so let's keep it moving. Let's move to the next example. Our next one is going to be the differential equation dy over dx. We have 3 sine of 2x. They've given us a condition that when our x value is equal to pi over 2, our y value is equal to 2. All right, so we need to get our x's and our y's together. We don't have any y's, so we don't have, in this particular case, we don't have any y's. So the only thing I have to move, and I know this is kind of hard to see, is this dx to the other side. So I get dy is equal to 3 sine 2x dx, and then I'm going to integrate both sides. This is understood to be a 1. So anytime you don't have a number there, you can just put a 1. And so we're going to go ahead and integrate this side. We get the integration of 1 is just going to be y, because that's the variable that we're integrating with respect to. And on this side, we're going to have to use u substitution. And so I'm going to let my u equal 2x. And so if I let my u equal 2x, then my du is going to be 2 dx. I need to get dx by itself, so I'm going to multiply both sides by 1/2. Remember, all numbers you can move to the front. I know I kind of skipped over that, but this is all the constants. I mean, you can move them to the front. So since this is a constant value, I'm going to go ahead and move it to the front. And then this 1/2, I'm going to go ahead and move it to the front as well. Now I just need to take the antiderivative of sine of u du, where the antiderivative of sine u is just going to be negative cosine u. And since u is equal to 2x, I'm now going to have a negative, because remember this is negative cosine, so this 3 positive 3 halves becomes a negative 3 halves. Everywhere I see a u, I'm going to put a 2x because that's what u is equal to. And since I'm taking the antiderivative, I'm going to have a plus c. And so now we need to find out what the value of c, and we're going to use the conditions that were given to us. Every time we see an x, we're going to put power 2. Every time we see a y, we're going to put 2. So this is my y value, so I know it's hard to see this, but this is a 2. This negative 3 over 2 doesn't change, and then since this my x value, I'm going to put pi over 2, so I have 2 times pi over 2 plus c. All right, so let's go to the next page to finish this up. And so if you look here, I have pi over 2 is equal to 3 halves cosine of pi. Well, how did I get cosine of pi? Because my 2's canceled out, because I had 2 times pi over 2. So the 2's just canceled out, and I'm only left with pi. So now I need to find out what the cosine of pi is. Well, the cosine of pi is negative 1. So if you see here, I am going to have 2 is equal to 3 halves, because a negative times a negative is a positive. So that means my c is going to be 1 half. All right, and so if you're having trouble with the math, the arithmetic on that, you can stop the video and do the work. All right, so everywhere I now see a c, I'm going to put 1 half. So I know that y is equal to negative 3 over 2. Cosine of 2x plus 1 half, and that is my answer. For example number 2, hopefully that was pretty straightforward. And let's go on to our last example, and we will be done with the video. Don't forget you will have a short quiz to go along with the video, so please do that. Yes, all right, so here we have a differential equation. We have dy over dx is equal to e to the x plus y, and anytime we have the addition of the exponents, we can write this as multiplication. So and don't forget our initial condition: when my x value is 0, my y value is equal to the natural log of 6. So let's look here. I'm going to go ahead and break this up into now multiplication. So I have e to the x times e to the y. And so I need to get my y's and my x's on the same side. So that gives me dy over e to the y times e to the x. And then, of course, the next step is to integrate. This side is pretty easy because we have e to the x dx. And so that's just going to be e to the x plus c. Now, if this was just e to the y and not a negative y, then it would just be e to the y plus e to the y. We don't need another c. But we have this negative, so we're going to have to do u substitution. So I did that over to the side here. My u substitution, my u is equal to negative y. My du is equal to negative dy. So that means that negative du is going to be my dy. So you can think about this as a negative 1. So I know that I'm going to have a negative sign in front of my integration. So I get negative, and everywhere I see a u, a negative y, I'm now going to put a u, so that's why I get the negative e to the u du. And we had already integrated this side. This is e to the x plus c. And so now, since I have e to the u, where the u is not negative anymore, so the antiderivative of e to the u is just going to be e to the u. And then I'm going to go ahead and multiply by the negative sign. And now I need to go back in and put this in terms of y. So everywhere I see a u, I'm now going to put a negative y. So this gives me negative e to the negative y is equal to e to the x plus c. All right, so now this is a negative exponent. So if I bring the exponent, the term to the denominator, then it becomes positive, but I still have this negative 1 in front. I only move the e to the y to the denominator, so negative 1 stays in the numerator. So this is really negative 1 over e to the y is equal to e to the x plus c. Still got some more work to do because we need to solve for c, and we need to solve for y. All right, so let's go on to the next page to finish this up. All right, so again, our initial conditions is when my x value is 0, my y value is the natural log of 6. So everywhere I see an x, I'm going to put a 0. Everywhere I see a y, I'm going to put the natural log of 6. And so that gives me, well, e to the natural log of 6, the e and the natural log are inverse functions, so they're going to cancel each other out. So this is negative 1 over 6. And anytime I raise anything to the 0 power, that just becomes 1. So I actually get 1 plus c. And so that is going to imply that c is equal to negative 7 over 6. Again, if you have to stop the video to see how I got the negative 7 over 6, then go ahead and do that. But I do expect you guys to know how to add and subtract fractions. All right, and so now everywhere I see a c, I now can put negative 7 over 6. Now I need to solve for y. And so in order to solve for y, I'm going to go ahead and multiply. Let me scoop this up so you guys can see this. I'm going to go ahead and multiply both sides by a negative 1. So this now becomes positive e to the negative y. But since this is a positive e to the x, it becomes negative, and then this negative 7 over 6 becomes positive. And so now I am going to go ahead and take the natural log of both sides. So again, the natural log is going to cancel out with the e because they're inverse functions. So this is going to give me a negative y. And then now that's going to be equal to the natural log. And I just rewrote this. I just put the positive number first. So that gives me 7x minus e to the x. And then the last thing that I need to do is get rid of the negative sign in front of y. So when I get rid of the negative sign in front of y, I need to multiply both sides by a negative 1. So that gives me my final answer. Well, the negative y becomes positive, but the positive natural log becomes negative. So the answer is y is equal to a negative natural log, and inside the parentheses we have 7 over 6 minus e to the x. All right, so this is the final answer and the final example. So that is the end of the video. Please email me, or you can send me, some of you guys have been sending me text messages. You can send me a text, however you decide to do it, and if you have any questions. All right, have a great day.